So let's talk about types of sampling. So selecting a sample. So your sample has to represent your population. That's really, really important because if I want to talk about a population and I don't have the whole population, I need to make sure I'm representing different subsets of that population so that their story and their information can be told. So a representative sample, as we call it, has to have the same relevant characteristics as defined by the population, and you can't favor one group over another. You have to be very unbiased when you do this. So you allow people to study a population without studying every individual of that population. So think about the US Census. There is no way we collect data on 100% of the people that live in the United States. We try to collect as much data as we can. And from that data we collect, then we try to talk about the groups that are within that data to the best of our ability. It's a valuable research tool. It always is. Sampling is a low cost way sometimes. It's easier to run your data, especially if you've got a huge population. It's just an easier way to do it. Okay, so let's talk about random sampling. So random sampling is when I select by chance or using random numbers. Each subject or human or thing has an equal chance of being selected. So examples are drawing names from a hat, random numbers, and here's a video that can tell you more about that. So what I've done with this in the past is when I was in my master's program, I had a 6 million person data set for credit bureau stuff. So each of us has a credit bureau from, like, you can get it from Equifax, TransUnion, or TRW, and we all have a credit history. So I had 6 million people's different credit history. And from there, I was going to make a model to see, who is the best person to give a credit card to. Well, a lot of machines won't run 6 million people worth of data. And I had over, I think, 400 variables, but I even cut that down to 25 variables, but I still had a hard time running that data. So what I did is I took a random sample. I told my computer at the time to give me the top, I think I did 1 million people. I was like, give me 1 million people from this data set and randomly select it. So I did a command and it gave it to me, and it gave me that 1 million people who were randomly selected. And I did that so I could be less biased and I could try to do my best guess of the people in that population. So another one is systematic sampling, where you take a certain number from your population. So say I'm going to take every third person. So I have this person, I have this person, I have the next person over here. You're starting at a certain point, and then you're taking nth subject. So again, you could do a random number generator and it says start at number 42, and then I'm going to take every 10th. So then I would take 52, 62, 72, 82. Okay. A lot of people use this. A lot of times it's used in industry. So if they have things coming down a manufacturing line, they may take every 20th car part to look at, or every 100th, something like that. This is commonly used, again, in manufacturing. Convenient sampling. I don't recommend this for any kind of research project, what you want to do. Basically what it is, it's usually what subjects are around you, and you're prone to create a non-representative sample because pretty much the people around you might have the same characteristics. So say like you're going to do a survey and you do all the people in your classroom who take math 1401 or business 3000 or mall shoppers. So what this does, though, is you're being very specific about who you're talking to, and they may have the same characteristics of you, and you might not really be aware of that. So this isn't a really good way to do this kind of sampling. Another thing is stratified, and here you see women and men. So stratified is when you divide the population into at least 2 different groups, strata. with common characteristics, and then draw some subjects from each group. So say I want to know students who are business majors versus students who aren't business majors. Those are my two groups, and say I'm looking only at GHC students. So I have students who are business majors and students who aren't business majors. And then I'm going to take a group from business majors or let me rephrase that. I'm going to take a sample from business majors and then a sample from non-business majors. And then I'm going to run my analysis. That is stratified sampling. So it gives you a more representative sample, and it helps preserve those certain characteristics of your population, even though you've subdivided that population. Okay, clustering. This one is stratified, and this one is what people get confused on. Clustering samples. And if you see the picture here, you see that they have 5, 16, and 28 picked out. So what does that mean? You divide your population into clusters, and a lot of times it's done by geographic location. So say counties in Georgia. And then you take certain counties and you ask everybody in those counties. And here that they're showing is they have 32 different precincts. They're taking precinct 5, 16, and 28, and they're going to ask all those members or collect data from all those members. It's a different way to look at sampling. So one thing I've looked at is, because you're a college student, there is national groups in Washington, D.C. that take data about you. And a lot of times if you fill out a survey, a national survey, that data goes to them. So a lot of times when I'm reading research for my dissertation, I'm reading these articles, and instead of trying to take all of the community colleges in the United States, what they'll do is they'll pick certain groups of community colleges. They might pick them from Georgia, maybe then one from Nevada, one from South Dakota, one from New Hampshire, because they'll try to find different geographical locations. They'll pick certain states and take all the schools from that state. That would be a cluster sample. And they use this a lot, like I said, in the government and the private research organizations. A lot of things are exit polls. You're going to see this during the election a lot too. Okay, so let's do some examples. A study is done to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following sample is asked how much tuition he or she paid for the fall semester. What type of sampling is each case? Okay, a sample of 100 undergraduate San Jose students is taken by an organization, and they organize the students by freshman, sophomore, junior, senior, and then they select 25 students from each. Okay, I have stratified my sample, remember? I've taken different groups, I've divided my population, and then I'm taking 25 from each group. So this is stratified. Even though I'd subdivided the population into 4 groups, I took the same amount from each of these 4 groups. So B, a random number generator is used to select a student from an alphabetical listing of all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in that sample. The big thing is this 50th, that they're taking every 50th student. That's a number. They're systematically taking every 50th student. So that's systematic sampling. Okay. C, a completely random method is used to select 75 students. Each undergrad student is in the fall semester has the same probability of being selected at any stage of the sampling process. I didn't break them up into groups. I didn't take everybody, and I didn't have any systematic stuff. This is a complete random sample. So this is how you would run a random sample. Okay. D, the freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4, respectively. A random number generator is used to pick 2 of these years. Say they pick 1 and 4, and then all the students in 1 and 4 are in the sample. That's clustering. I had 4 different groups. I picked 2 of these groups. In these 2 groups, I asked everybody, or I collected all their data. Okay. An administrative assistant is asked to stand in front of the library one Wednesday and to ask the first 100 undergrad students he encounters what they paid for tuition in the fall semester. There's 100 students in the sample. Okay. So they just sit in front of the library on a Wednesday and they ask students questions. Okay, well, what about students who are online? What about students who only go on at night? What about students that don't have any Wednesday classes? This is a convenience sample. There's really no research to what they're doing. They're just going out there and asking questions. I would not be able to present this data as scientifically accurate because I really haven't looked at all the students that I could look at. I wasn't random about it. I didn't sample correctly. This is just convenience.